The two dimensions of space make a plane. Each coordinate on the plane is x and y. And you can define any point on this plane with those two coordinates. 3 dimensions. You have your x and your y just like before, except the paper's been tilted up, and you add the z-axis. Now you have a point in 3-dimensional space defined by x, y, and z coordinates. X, y, and z coordinates define the position of point A, right there, as 4, 2, 2. Now we take the graph that we just did on 3-dimensional space and we squish it down to 1 dimension and we call it just position. And on this axis we have position A, B, and C. And the position is graphed against time. And this gives your position in our reality. Every position in space linked to a time will give you your place in this reality. Each point is a moment in time at a specific position. An iPhone will record one's world line by using the GPS coordinates and the time. And Einstein first thought about this when he was doing general relativity. Now let's look at this graph. This graph still has our position here, and it has time here. The graph we're just looking at with position versus time has now been flipped up on its side and put right here, just like we did when we were showing you 3-dimensional space. But this time we add another axis at right angles to this plane. This plane right here represents our physical reality. Anything back here we can't see because our senses cannot pick it up, so we can't see it. But that doesn't mean it doesn't exist. Just like there are 3 dimensions of space, there has got to be 3 dimensions of time. We just cannot comprehend it. Now, any position on the world line back on this graph can be calculated by plotting your point A versus 1. This might be a 1 hour, 2 hour, 3 hour, 4 hour. So you have your position versus time. So we have our position versus time right here. Now if a guy standing in 3-dimensional space, which is represented by this line, is to throw a frisbee, the path that his frisbee traces out through 3-dimensional space is his world line. Each one of these dots represents a moment in space-time, an instant in space-time. Because one instant is here, the next instant it has moved to somewhere else, but it's still not here, it's somewhere else. Maybe here, here, any place in between. The position of this object is given by its time here, its position here, and its alpha time right here. Time t is, we'll consider that proper time. That's 1 dimension of time, and that's the only dimension of time that our senses can pick up. Back in here is the 5th dimension. Here is our plane of reality, just like we're talking about before. It's position and time. If a particle's location in 5 dimensions is given by the coordinates t, p, alpha, and alpha is not equal to 0, then the particle is in superposition. And what is meant by this is, if we were to observe that double slit experiment, when they were firing 1 electron at a time through the double slits, the electron would go through both slits at the same time, interfere with itself, and make an interference pattern on the wall. Now, how can it be 2 places at once? Well, it can't. It has to be in superposition to be in two places at once. And how this works is to find your place in five-dimensional space, you need TP and alpha. Now, since we can't see anything back here and we have a TP and alpha coordinate of 1, 5, 4, that means it's not in our plane of existence. It's here. We can't see it. Particle is not in our reality. It's in the reality out here. We can only see things that are in here. So just because this particle is showing up here at this time doesn't mean we can see it, because it has a 4 for the alpha. So the hardest part of this to comprehend is this part right here. Here we go again. Now we're going to use two particles. And these represent the particles that pass through the double slits. One particle passes through the slit at these coordinates, 2, 1, 0. This is a time, that's its position, and this is time. As you can see in our proper time right here, these two hit at exactly the same time. So it gives us the appearance that these went through the double slits at the same time. But in reality they did not, because this one went through the time as time 2, 0. Because alpha is 0, proper time is 2. Proper time is 2, alpha time is 1. So in reality, these hit at different times. One hit in our plane of existence, the other hit outside our plane of existence. When observed, the wave function that causes superposition collapses, and the observer only sees one particle. What we have here is we have our position versus time plot, and we have our plane of our reality, what our physical world is, and that is space-time. 3 dimensions of space, 1 dimension of time. Back here is alpha time. This is where all particles exist in superposition. They behave as waves all when they're out here in alpha time. And the instant we use this observing device with the human eyeball or something else human made to observe these particles, the particle wave function collapses and the particle fixes to our reality. Here's the same plot again with position, time, and alpha time. Here's our frisbee being thrown that is showing the world line, its position in our physical reality, or its position in our space-time. And it can be anywhere and everywhere at once until we choose to observe it. And the instant we choose to observe it, it becomes fixed in our reality. So all these will zap to right there, and that's where it is, and it just continues on. So each one of these is a moment in time that is pulled from alpha time. Very interesting. And it is possible for anything in here, back here in the alpha time quadrant, to be anywhere and everywhere at the same time. This is the place that's thought of as the spirit world.